Hello Cloud Pedagogians, welcome back to Cloud Pedagogy. In the last session, we have discussed about what is relational database and relational database management system. In today's session, we are going to discuss about relational database service in Amazon, which is Amazon RDS. So what is Amazon RDS? Amazon RDS enables you to create and manage relational databases in the cloud without the operational burden of traditional database management. For example, if you sell healthcare equipment and your goal is to be the number one seller in the India, building out a database doesn't directly help you achieve that goal, though having a database is necessary to achieve that goal. So Amazon RDS help you offload some of this unrelated work of creating and managing a database. You can focus on the tasks that differentiate your application instead of infrastructure related tasks such as provisioning, patching, scaling, and restoring. Amazon RDS supports most of the popular relational database management systems ranging from commercial options, open source options, and even an AWS specific option. Here are some supported Amazon RDS engines. For the commercial purpose, we can use Oracle SQL servers. For open source, we can use MySQL, PostgreSQL, MariaDB. For cloud native applications, you can use Amazon Aurora. Here note that the cloud native option, which is Amazon Aurora, is a MySQL and PostgreSQL compatible database built for the cloud. It is more durable, more available, and provides faster performance than the Amazon RDS version of MySQL and PostgreSQL. In a simpler way, I can say Amazon RDS is a service that makes it easier for you to set up, operate, and scale a relational database. We already got to know what is relational database. Next step to understand in the relational databases are DB instances, which are database instances. Just like the databases that you would build and manage yourself, Amazon RDS is built off of compute and storage. The compute portion is called the DB instance, which is database instance, which runs the database engine. Depending on the engine of the database instance you choose, the engine will have different supported features and configurations. A DB instance can contain multiple databases with the same engine, and each database can contain multiple tables. Underneath the DB instance is an EC2 instance. However, this instance is managed through the Amazon RDS console instead of the Amazon EC2 console. When you create your own DB instance, you choose the instance type and size. Amazon RDS supports 3 instance families. Standard, which include general purpose instances. Memory optimized, which are optimized for memory intensive applications. Burstable performance, which provides a baseline performance level with the ability to burst to full CPU usage. The DB instance you choose affects how much processing power and memory it has. Not all of the options are available to you, depending on the engine that you choose. Much like a regular EC2 instance, the DB instance uses Amazon Elastic Block Storage, which are EBS volumes, as its storage layer. You can choose between 3 types of EBS volume storages, which are like general purpose, provisioned IOPS, and magnetic storage. I'm not gonna go through these types of EBS volume storages, but just to know. Next, we'll work with Amazon RDS in an Amazon Virtual Private Cloud. When you create a DB instance, you select the Amazon Virtual Private Cloud that your database will live in. Then you select the subnets that you want the DB instances to be placed in. This is referred to as a DB subnet group. To create a DB subnet group, you specify the availability zones that include the subnets you want to add. Next, the subnets in that availability zone where your DB instances are placed. The subnets you add should be private, so they don't have a route to the internet gateway. This ensures your DB instance and the data inside of it can only be reached by the application backend. Access to the DB instance can be further restricted by using network access control lists, which are ACLs and security groups. With these firewalls, you can control at a granular level what type of traffic you want to allow into your database. Using these controls provide layers of security for your infrastructure. It reinforces that only the backend instances have access to the database. Next, we'll see how to use AWS identity and access management policies to secure Amazon RDS. We have already known that network ACLs and security groups allow you to dictate the flow of traffic. If you want to restrict what actions and resources your employees can access, you can use IAM policies. We got to understand about securing in databases as well as the data inside of it. The next thing we need to understand is backing up our data. You don't want to lose any of that precious data or information. To take regular backups of your RDS instance, you can use automatic backups or manual snapshots. What are the automatic backups? Automatic backups are turned on by default. This backs up your entire database instance and also your transaction logs. What I mean here is entire database means not just individual databases on that instance. When you create your DB instance, you set up a backup window, that is the period of time that automatic backups occur. Typically, you want to set these windows during a time when your database experiences little activity because it can cause increased latency and downtime. You can retain your automated backups between 0 to 35 days. You might ask yourself, why set automated backups for 0 days? The thing is, the 0 days setting actually disables automatic backups from happening. Keep in mind that if you set it to 0, it will also delete all existing automated backups. So this is not ideal, as the benefit of having automated backups is having the ability to do point-in-time recovery. If you restore data from an automated backup, you have the ability to do point-in-time recovery. Point-in-time recovery creates a new DB instance using data restored from a specific point in time. This restoration method provides more granularity by restoring the full backup and rolling back transactions up to the specified time range. Next, we'll see manual snapshots. If you want to keep your automated backups longer than 35 days, then you will use manual snapshots. Manual snapshots are similar to taking EBS snapshots, except you manage them in the RDS console. These are backups that you can initiate at any time that exist until you delete them. For example, to meet a compliance requirements that mandates you to keep database backups for a year, you would need to use manual snapshot to ensure those backups are retained for that period of time. If you restore data from a manual snapshot, it creates a new database instance using the data from the snapshot. Looking at both options, you may get doubt like which backup option should I use? The answer almost always is both. Automated backups are beneficial for the point-in-time recovery, where manual snapshots allow you to retain backups for longer than 35 days. Finally, keep redundancy with Amazon RDS Multi-Availability Zone. When you enable Amazon RDS Multi-AZ, Amazon RDS creates a redundant copy of your database in another availability zone. You end up with 2 copies of your database. A primary copy in a subnet in one AZ and a standby copy in a subnet in a second AZ. So that's all about basics in Amazon Relational Database Services. Hope you enjoyed the session and wish to see you again in my next video. Until then, take care.